Technical SEOs are investing thousands of hours into entity clarity and FAQ schema, only to watch their WordPress sites vanish from ChatGPT and Claude citations. But a sudden server-level error halts the bot before it reads a single word of that optimized content. This discrepancy exists because answer engines do not index web pages like traditional search engines do. Googlebot indexes asynchronously, crawling and processing data on its own schedule. Generative engines operate on a synchronous, live retrieval pipeline. They fetch data the moment a user asks a question. If a server stack fails to deliver the raw response within a strict time and rendering budget, the retrieval fails. Every piece of schema and content optimization is ignored. The AI Crawler Reachability Ladder defines the precise hierarchy of technical gates a crawler must navigate to extract a citation. Tiers 1 and 2 represent the network layer, where firewalls and IP routing dictate basic crawler access. Tier 3 is readability. At this level, the server's rendering logic determines if the crawler can actually see the content. Tier 4, retrievability, governs the time budget and concurrency requirements of live AI fetching. At the peak sits Tier 5, citable. This is the only level where content structure and schema provide value. AEO is a linear dependency stack. The content tier is unreachable if the server fails at any of the bottom 4 levels. We begin at the bottom of the ladder with network-level reachability. Most access failures stem from a misunderstanding of how AI operators identify their bots. Operators run separate crawlers for training and search. OpenAI uses GPT-bot for model training, but they use OAI-SearchBot for ChatGPT search answers. Blocking the training bot does not affect search visibility. This creates the silent 429. Web application firewalls, bot fight modes, and rate limiters execute before the application layer is reached. An aggressive firewall will issue a 429 or 403 error to a legitimate AI bot based on traffic patterns. As shown here, the request is rejected before it can reach your robots.txt file. The administrator sees a permissive robots.txt file and assumes the site is open, unaware the firewall dropped the request upstream. These upstream blocks do not trigger errors in Google Search Console or standard analytics platforms. A proper audit requires you to grep the server access logs for OAI-SearchBot and Claude-SearchBot to verify the actual HTTP status codes returned. IP allocation often determines whether these silent blocks occur. On a shared IP address, your server-level identity and reputation signals are pooled with every other account on that address. Shared IP environments are more likely to trigger blanket firewall rules or rate limiting compared to an isolated, dedicated IP. Application-level permissions are ineffective if the infrastructure or IP reputation rejects the crawler first. Tier 3, readability, governs what data the crawler successfully parses from the server's initial response. Googlebot uses a headless browser to execute JavaScript and render the DOM. It can see content that is assembled in the browser after the page loads. Retrieval bots like Claude-SearchBot and Perplexity bot do not run headless browsers. They only parse the initial raw HTML provided by the server. This split screen shows the danger for WordPress sites using client-side JavaScript hydration. The browser DOM shows the content, but the raw code returned to the crawler is empty. Dynamic accordions, JS-injected FAQs, and headless decoupled frontends are invisible to generative engines. This failure is binary. There is no secondary rendering pass or partial credit. A site can hold position 1 in Google while appearing functionally blank to ChatGPT. The Chrome DevTools Elements panel is an unreliable audit tool because it shows the post-hydration DOM. You must use the View Source command to see the raw server response. Using a curl command with a forged AI user agent allows you to bypass the browser and see exactly what the bot sees. Server-side rendering is the threshold for existence in AI search results. Tier 4, retrievability, covers the timing constraints of generative search. Traditional core web vitals measure perceived speed for users, but AI retrieval depends entirely on uncached time to first byte. AI fetches occur in the milliseconds while a user waits for a response to generate. Measuring cached response time is a vanity metric. Bots frequently pull from deep, uncached archive pages that trigger the full server queue. If a server process queues, the timer expires and the connection severs. The AI pipeline immediately reroutes to a faster source. Server concurrency and PHP worker limits determine whether your site remains available during these crawls. When workers are exhausted, the server throws intermittent 5xx errors, a condition known as flapping. Google will retry a 5xx error later. An answer engine will permanently omit the site from that specific user's generated response. Frequent short outages lower a crawler's sampling frequency, causing long-term damage to your visibility. In a live retrieval ecosystem, a slow, uncached response is functionally identical to being offline. The window of opportunities slams shut. The Reachability Ladder represents a strict order of operations. Schema and traditional content strategies only provide value if the 4 infrastructure layers below them are stable. This explains why the recent focus on the llms.txt file is largely misplaced. Major answer engines do not currently use llms.txt for retrieval or citations. It is a minor convenience for agentic browsers. It should not be prioritized over core infrastructure. Your AEO audit strategy requires a more rigorous approach. Stop relying on SEO plugins. Open your command line interface. Use the curl command to verify raw HTML rendering, and grep your access logs to identify silent firewall blocks. Successfully optimizing for answer engines requires the rigorous, stack-based discipline of a systems engineer.